Okay, so looking for clues in the question again. It's not too hard to find. It's arithmetic. So the sequence is arithmetic, and it talks about u of n and s of n. So the first thing we're going to do is write down our formulas. U of n is u of 1 plus n minus 1d. And s of n equals n over 2 into 2u1 plus n minus 1 into d. That looks good. Now let's have a little look. We've got u of 3 equals 7. We've got s of a equals 20. So let's use the information, substitute, and find out what's going on. Remember, this is a 5 marker, so could indicate it's a bit of work to do. So 7 equals u1 plus 3 minus 1d. Here, tidy up. 7 equals u1 plus 2d. Over on the other side. 20 equals 8 over 2, 2u1 plus 8 minus 1d, tidy up here, 20 equals 4, 2u1 plus 7d, divide by 4, and you can see that it's just simultaneous equations. Here's equation 1, here's equation 2, you can line them up underneath each other if you like. That might make it feel a bit better. In fact, I'll just drag the 2 over to here to line them up. 5 equals 2u1 plus 7d. Now what I'm going to do is I'm going to times equation 1 by 2 and write it underneath. 14 equals 2u1 plus 4d. I'll call that equation 3. And now you can see that I've got the number of u's lined up, so I am going to do a subtraction. I'm going to do equation 1 subtract 2, subtract the left hand side, so we've got negative 9, subtract the right hand side, disappears, that becomes 3d, so we've got d equals to negative 3. Okay, once I've found d here, I need to substitute into equation 1 or 2 to find u of 1. And so let's do that. We'll do subs in 1. We've got 7 equals u1 plus 2 negative 3. That gives us u1 equals to 13. And let's not finish there. Let's just actually write out the first few terms. The first term is 13. D is negative 3, so it goes 10. It goes 7. It goes 4. 1. Negative 2, negative 5, and then you can actually check and confirm that the sum of the 8 terms is 20. So you got 1, 2, 3, 4, 5, 6, 7, 8, and you will see indeed that is indeed sum is 20. And once we've got that, we can go to part B. We want the sum from 3 to 10. That's of u of n. So remember what u of n is. U of n is u1, which we now know is 13, plus n minus 1 times by negative 3. So that's what we're trying to find the sum of from 3 to 10. Now there's a number of ways of doing this. You can use your original ideas, or you can generate a new series just using sigma notation from here. And I'm going to tidy this up a little bit. This is sum from 3 to 10, n equals 3. And when you play with this, you get 16 minus 3n. So that's the nth term rule for the series. And so if we just generate the first few terms, we'll get to see what's going on. So remember how sigma works. Here is an nth term rule, and we substitute n from 3 integer values up to 10. Okay, so substituting 3 in, that's 16 minus 3 times 3, that's 16 times by 9. Then we've got 16 minus, substitute 4 in, 12. Then we've got 16 minus 15, 16 minus 18, and so on. Okay, and what you can see there is, let me just put the page in. We've got 16 minus 9 is 7. then we've got 4, we've got 1, negative 2. Now this is 7 plus 4 plus 1 plus negative 2 plus, and of course the last term is when we substitute 10. I'm just grabbing here. The last term is when we substitute 10 into this expression here. So 16 minus 30 is negative 14. Okay. So you can, this is from 3 to 10. 10 minus 3 is 7. These are 8 terms. So we do S of n equals, n over 2, and I'm going to use the other formula, u1 plus un. Remember, these are given in the formula book, but it's really useful if you have them to hand. And for this series, n equals 8, u of 1 this time is 7, and u of n equals to negative 14. So let's substitute those in. That's my alarm. Let's stop that for a minute. And that's into u1 plus negative 14, and this is 4 into negative 7, this is negative 28. Now I did see some students do this slightly differently, and they worked out, if we go back to here, they saw that this was from 3 to 10, so they worked out 1 to 10 and subtracted 1 and 2. There's alternative ways of doing it, but I think that's a nice way of getting it.